basically, I'm trying to do this is on it's called radiomography, but it's based on tomography. So definition, radiomography is using radio to interpret information around us. So you get like a visible light spectrum, all the things we can see, but radio wave is the first one. So you can there's a sort of so everything can fit in the radio wave. Visible light is a radio wave and visible light, etc. But we're gonna use radiomography and what tomography. So we've got topology, which is like the surface area. Now we've got tomology, which is the area of the surface in the surface. So basically, the if it's like it's a plane, you got the area thickness of the plane with dimensions. That's what tomography is about. So without further ado, let's start. So I'm trying to use now obviously I've got my notes here and I've got a work example and I've got to show you everything I'm doing. Better ones of the rule. So I'm really just trying to use radio waves to see, so basically to see the world around. And basically it's a tier 3A bound, so I'm using the Rift library, or what I call the Rift interdependency library. How this works? Before I continue, so what is the interdependency library? So interdependent is means you don't really read it because it's like you use that, so you get a dependency A, B, and C. This is a start. This is a dependency start. This is a bit N. So this is a dependency matrix here. B. So this is matrix. So this is basically with basically you go A to B to C and consuming C. Now C is depends on B. So the problem here is the tomography layer. At least be careful. The tomography layer is like B is A. So B is dependent on C. A is C. So it's like it's not coupled. So you have to decouple it. So A start. Basically A has 4 starts. So A has 4 starts and 4 ends. So there's a 4x4 matrix for starting. So if ray A is resolved, all the ends are resolved. So A will signal end. But A starts because C is it depends on B and A. C will have 4 starts. Twice as many starts. If A has 4 starts and 4 ends, that means 8 end starts, 8 start pairs, and that means C will have end start. So basically end and start. So end and start, but that'll be 8 times 3, 8 to the power of 3, which will be 24. So 24 starts end. So the problem is we have to cut this off. So interdependence, we have to cover the dependency of mid. So basically we bootstrap A to B, and B will resolve C. So basically it doesn't copy anymore. So the idea of this is literally just to split into some A start end is equal to B start B end. So B end is A start, it's basically B end is equal to A end, and when B end, A can escalate A end, A start to end at the couple to you don't have to have any chaining. So A basically is a shorter pound, but the only thing you have to worry about is so you get the matrix A B sharing A and A B and A B and A B and A B and you get only the end sharing A and B, but B then contains A start, A end. So basically you get A end in A B, but you get B start independent. So basically you have basically using thermodynamic principles. My model and basically get this model on thermodynamic principles. So basically, I think I'll open this video here. So we get so basically if this number is 0 180 minus 180, this is 180 0 or 0. So this way it works. So this is how it works. So you get a thermodynamic principle here. So this thermodynamic basically is a root stage 2 1. So if you want to pack it, so if I want to go to C from A is counterclockwise B. So basically you can use A or B, but the halfway point is AB. AB, and this will be the start and where the cutoff point. Basically this is 90 degrees polar system. So here we get 90 degrees, 90 degrees, 90 degrees. It's like you need basically this is like the end of A. Because A is half of N, AB is half of is A of A, but it's 90 degrees polar. So all the energy is measured in like the polar quantum systems. For example, to measure the artifact A start A to B, AB the 90 degrees. So you can use the area. So 90 degrees times 2 pi r. If the radius is the radius is what the radius is space time auxiliary, the space and time. So if if the radius if the space the radius of the space is volume is the radius of volume 3 cubed, that'll be 9 what 9 space 9 centimeters cubed. Now the time will be 15. Oh, 3 times 2 to the power of 3, 3 times 3 is 6, 9, 27. So get 27 centimeters cubed, 20 centimeters cubed, which is the space, in bytes, and that'll be 27 divided by the time. Let's say 10 seconds, and that'll be 27 cubed divided by 10. That'll be what? 0.27 to the power of 3. This is 2.7 to the power of 3. 2.7 to the power of 3, 2.7 bytes to the power of 3, which is half of 10. That'll be per 10 seconds. And that'll be the unit of the halfway travel, or where A reverse spacing. This after 10 seconds reverse out. Basically, you use this entropy to calculate force of negative force of positive force, net force equals 0, and based on thermodynamic principles, and work with them, but you get the two, and you get halfway. So you use half the speed, based on, and you get the other ones. You get pi r squared. So pi r squared is simply so you have the space of pi. Sorry. So the radius is 3. 3 cubed is the volume space. So I even double the space. It's 29. It is wrong. Basically, you use the standard formula for polar rotation, which is like 2 pi r and pi r squared. Pi r squared times 3 divided by 1 times pi r squared is like pi 3.14 times 180, 180, which is just A to B, 180, A to C, A to C, A to B, full resolution, of the whole true dependency. So the goal is to never have this coupled again. Basically, never have dependence coupled again, because you don't need to couple dependencies. Whether it's a loaded electromental library or this is what artifacts. Applications used to model some kind of a folder hierarchy, lost and found. Programs that always know where your lost and found are, because they're fully decentralized, they're copied and self-governed, so they really know where the point when you lose a file, when you move a file into some kind of when you forget where your file is. So basically, that's why I call the Rift interdependency system. So a Rift system, Rift is 3, 000 is a tokenizer. Stage 1 is tokenizer. So this I stage 0 and then 2 is parser, and 333 is AST. So we integrate artificial necessity with R. You get this kind of dependency because we're using C for building a library. So for example, if you have the encoding 101, which is the binary encoding for 001, you get you resolve some sort of stage X, Y, Z. So you resolve some kind of module X, which is like a file, C file. Now you get Y. Now you get the linkable format of system, which is where the tomographic system, so basically works in area tomography. So basically, for example, I got the number 2 pi squared. So if I have the artifacts 3 squared, 3 cubed, I get 3 cubed. 3 times 3 squared is 9. 9 cubed is what? 27. 7 bytes cubed. Now this is the volume I have now divided by 10 seconds, 2.7. Now this bytes now 2.7 bytes cubed. Now I have what? One more, the area. Now my area is pi 3.14 r cubed. So 3.14 times pi is 2.71 2.7 times pi divided by 180. So 2.7 pi r 2.7 divided by 180 0.015 times 90, and this is 1.35 seconds. So basically, I know the exact time, which is meant to be corner form. I've resolved n. So this takes 1.35 seconds to resolve this independency, this file, based on 1 unit. So basically, you get a 111, which is encoding for binary. The left shows you get 1 on the means that you resolve the x system, the x-axis of your code, your file. Y, you resolve the system, the integration test, the riff test. And Z, you have the system code. You can use it. You can run it on your own system, like with the dilib, dynamic library, zip, etc. You can run it and execute it. Okay, thank you guys for watching this video. This is to riff interdepncy. Thank you.